Hello, everyone. Yeah, thank you to attending this talk. We'll talk about securing content distribution with RSTUF. RSTUF is an incubating project at OpenSSF. Yeah, my name is Kairo. I work at TestifySec as an open source engineer. I'm also involved in the many open source projects related to the security supply chain. I'm a maintainer of RSTUF, Python TUF, and also some projects from in-toto for attestations that I will cover a little bit here. And today with me, we have Martin.
Hi from me. Yes, I'm Martin. I'm a senior Python developer in Consensus, and I have been contributor for years already, and I'm also a maintainer of RSTUF, and I have contributed to Python TUF as well. And the first question we'll ask today, which is normal to ask when we start a talk like this, is why do we protect a repository? It's an obvious one, but we want to cover it. And of course, it all comes back to artifacts in our repositories. And what will happen if an artifact in our repository gets tampered or is changed? What will be the consequences? And actually, we don't know what are the consequences because once a package is delivered, you don't know where it will end up. So it could be many other developers' machines and so on down the line that are vulnerable to an attack. So it seems it's an important question. And what is one of the traditional ways people have protected their repositories? It's by signing their artifacts, which is a good measure. It works. But I'll tell you my opinion on why this is not enough. First, a question we should ask: if a person is responsible for signing, what will happen with his key when he leaves the organization? Or what will happen if a key gets compromised, which happens all the time? Also, what will happen if we have millions of packages, such as in the case of PyPI, but you can easily have millions of packages in your own production environment as well? And then, when something bad happens, how do you notify your users at scale which key they should trust, which key they should revoke and not trust anymore? So those are really hard questions, all of them, and that's why the update framework was created with the idea to solve those problems and more. And it signs all the artifacts? No. It actually doesn't sign your metadata files. What it actually signs it doesn't sign your artifacts, it signs your metadata files. So it signs deterministic number of files, and that allows it to easily notify your TUF clients which keys they should trust. They can easily get this information with an update. And also TUF provides freshness, consistency, and integrity in the whole system. If you want to learn more about TUF, feel free to speak with us after that. But the update framework itself is tough. And why it's tough? The update framework, first and foremost, is a specification on how to do an update. This specification is complex to understand, and when you try to understand it and to implement it, you understand that it's mostly concentrated around TUF client code. This is a problem because you need also a repository. And when you try to create such a repository, you realize that it costs a lot. And when developers do that, they understand in the end that they have lots of code to maintain. It could be done, but it's hard. And I will say, finally, it's easy to mess up doing TUF processes and to be in an inconsistent state and to don't know how to go back. And that's why, that's one of the reasons why we have created a repository service for TUF. RSTUF, for short, was implemented after we focused on implementing PEP 458. What is this? This is a design proposal to integrate TUF into PyPI. And during that time, a friend of ours, Yussi, during a conference said this sentence: repositories are more alike than they differ. And that is actually true. And we focused on how to abstract the TUF complexity and make it easy for different repositories to use TUF in their systems. So in order to do that, we realized that the design should be easy to deploy, scalable, and easy to integrate. By easy to deploy, we are using containers and command line interface, something traditional, and Helm charts so you can easily integrate RSTUF with your Kubernetes clusters. And some of the main RSTUF features we want to mention. First, it's really nice that you can start your whole TUF repository by just following CLI guided process. So it's really easy to set up your TUF repository. But then it's normal that you already have lots of existing artifacts. So we introduced a way to import millions of artifacts easily as well. But then we also allow you to add, of course, add and remove and manage those artifacts. It's important to note here that RSTUF doesn't host those artifacts. It's only connecting to your S3 bucket or the place you're hosting them there. Then we also allow key rotation and revocation when something bad happens or a key expires. And finally, we also allow delegation of trusts. And where do you put RSTUF into your distribution platform? The place you put it is after the distribution platform finishes its job, what you will do is actually make an API call to RSTUF repository with a simple API call. There is no need to change any of your processes. That's all it takes. And then in CI/CD, what you will do, actually you will do the same. After the continuous deployment is done, you will also add an API call to the TUF repository, so it could have the latest information. And I want to share a few use cases that you can use RSTUF for. First, as we said, the original use case was to implement PEP 458. This work is ongoing and it's currently under testing using RSTUF to do that. Also, RubyGens got interests into RSTUF and they're currently testing in a staging environment RSTUF. And it's a work under progress as well. Then you can also integrate RSTUF with JFrag Artifactory or any other storage you have for your artifacts. And that was demonstrated by Kairo in KubeCon this year. And I mentioned S3 buckets, and actually you're not tied to any storage specifically. And now I'll give the word to Kairo.
Yeah, I'll give more clarity in how our stuff works, demonstrating some examples here, how you deploy, how you could use, to make it more realistic for everyone, because I noticed this from the previous talk. So one thing that I need to highlight is our stuff requires two services to work. It requires a PostgreSQL database and also a Vault key or a Redis. So, but this might sound a little bit complex to deploy, but recently we come up with the RSTUF Helm charts. If you are familiar with Helm charts and Kubernetes, you can use this to deploy our stuff. And we create one Helm chart just for demo. If you want just to start it in your machine, use Minikube, for example, and I want to test it, you can easily deploy this demo and start playing, and everything will be set for you to run. But let's see how it could be used in the real world. So I'll give the first example. Let's say that my organization or my project, I want to secure the release process, right? Let's say that I have my Git, my CI/CD, and everything that I build as artifact, I store in such storage like S3, or could be Nexus or JFrog. Let's say that I have two main, that case here, the main buckets, that staging and production. And let's say that those are my URL. Let's say that when I put something in the staging, my continuous integration will pick up it, do some tests, an environment test, and when it is good, past everything, I will push it to production. Okay. How it would look if I have an RSTUF. So let's say that I begin. I just introducing this to my environment. So it will start with what we call as a ceremony. Ceremony is creating the TUF metadata, signing it, and define who will be able to sign and use that. We have two ways to use this. Basically, we can have beans. We call beans is like RSTUF. We will use our online key, let's say a key from the KMS, and will sign it by itself. So you don't have to interact with that. But you can have also custom delegation. It means that you delegate this signature for some certain people that should go there and review it and approve and sign it. So, and here we see a lot of integrations that are cool, and I will show that. Beans, for example, is how used by RubyGens and PyPI, because they have millions of packages flowing there. So, and the custom can be used when you have this release process. Okay. Basically, I will start creating my staging, but for my staging, I don't want to sign. I want that everything that I release as a staging can be right away used and signed by my RSTUF, because I trust in my RSTUF deployment, and I want this to sign. It's my repository sign. But for production, I want to do different. Everything that goes to production, I want to some certain people from my organization that signs it. Let's say that I want my project managers to sign, or my release manager to sign this artifact. The cool thing that you can see here, I can be keyless as well. I can use RSTUF supports SIGSTOR, so I can use SIGSTOR to sign the stuff metadata as well. So what I'm doing here, I'm creating those setup with for production that will be signed. So you see two sets: staging, no signatures, and production signatures done by future SIGSTOR people. So, and here I'm doing the root metadata. Who is the root metadata? It's those that can go here to the TUF metadata and change, add delegation, remove delegation, revoke keys, add new keys, rotate the online key. So I'm defining here two people that are allowed to do this. In that case, I'm using SIGSTOR as well to sign. I want to show one nice feature as well, is that for my online key, that's online that my RSTUF will use to sign things when I say that I don't want to sign. I support, RSTUF also support KMS keys, HashiCorp Vault, or you could even use a file. So I'm using here a KMS example. I have an alias for my key, and I define this key, and I can rotate this key as much as I want. And here you see I'm using just SIGSTOR to sign it, so keyless. I don't need to hand keys here. If I can just revoke identities that are allowed or not to sign. So I have here right now my RSTUF setup done, and what I'm gonna do now is show, let's say that my CI/CD, when I build a package, I just release this package to the staging. So I'm just defining that it will be in the staging. I'm not sending the file itself. I'm just collecting the metadata for this file and send it to the RSTUF API. You don't store it twice. So there's no signatures there because it's signed by the online key that I demonstrated, the KMS key. But when I release to the production, I want, for example, that my test engineers certify that everything went well and they sign it to validate it and make it available. So what you see here now, I'm using my SIGSTOR again to sign this metadata. This is an example how you could integrate to the CI/CD and releasing. It means that in the other side of this, the clients, when download these artifacts will be signed and trusted by defined root metadata. So going next, I want to give the second example. It's how you can use the RSTUF and easily integrate to other services, right? I will talk a little bit about in-toto here. I'll be very quick. And who wants to discuss more about that topic can reach out and we can discuss. In-toto is a framework as RSTUF, a framework that designs how you create attestations, right? What are attestations? So you have heard about SALSA attestations. Actually, SALSA attestations are in-toto attestations as well. So when you create attestations, what's the idea of the attestation? You can have everything that it's running while you are building your package. What are my environment variables? What are the commands that I used? It's kind of log in a attestation metadata that contains all the information about your building process. So you can look after and see if something was injected or a malicious command was added while you're building that. So when we talk about in-toto, we have a sub-project in in-toto that's called Archivista. Archivista actually is a storage, right? A storage that you can store all your attestations and policies there. So when you store the attestations there, it gives you back a graph that you can query about an artifact and get all the attestations, and you can visualize what is going on during your build system. Or, for example, you can also store policies that you can apply policies to the attestation that I will explain in a second. So, we have another product that's called Witness. Witness is used in in-toto for generating these attestations. Let's say, when I do my make build to build my product, I will have all the information about the GitHub, environment variables, and I can see what is there. And it can also verify. And how it verifies? I can write policies that I say what I expect when I build this product. I expect this command. I don't want to see nothing else. I don't expect environment variables injected in there. So you can verify that and make sure that during the build provenance, everything is as expected. And Witness can work together with Archivista. It means that Witness can, based in a product, let's say an artifact, a SHA, it can go there and query and retrieve all the attestations, and you can apply policies to this and verify if your build was correct. So then this integration is very cool, but Archivista is really not, there is no this distribution of policies, for example, are not secure by authorization, authentication, but you could use our stuff to help it. So we built recently, last week actually, a new feature in Archivista that allows you to integrate with our stuff. You just need to declare the publisher that you want and the RSTUF URL. And what happens actually is every time that you generate an attestation, a policy, and store it to Archivista, automatically it will go to RSTUF. Because later, if you have a distributed witness, for example, that will check and validate these attestations, it can use RSTUF to make the trust to say, yes, I trust in the policy, and I will retrieve this policy and verify if the attestation, because someone could just write a policy that allows everything, including an injection command or injecting of an environment variable. So this is a short demo about how this integration works. So basically what you see here, I'm creating again a delegation role for Archivista. And then I will put also keys, the 6 store keys, to sign these attestations that will be stored in Archivista and RSTUF delegation. So again, I'm using 6 store here to define who will be the signers of that, because in that case, I want that all policies that are created are kind of reviewed by someone. So with that, I can say that someone creates a policy, but I review that, and this policy will be used later. Just, oops, sorry. Come back here. Yeah. So I want that, yeah. Here I'm generating a policy. So I'm generating with some attestors, like the command what was used to run. And I'm signing here the policy, but what is a policy? As I mentioned, I can define what the rules for the attestations to pass. So, for example, let's say in that case here, it's very simple. I'm saying that I need to have an attestation about the command that I run, the product, the final artifact, and the environment variables. But I could go here and put, for example, regular rules to check if, for example, if the tests were passed, if 99% of coverage, or if the environment variables are limited to a set of environment variables, or the type of machine. Yeah. So what I'm gonna do now is store all these artifacts that are attestations and policies in RSTUF, but without using RSTUF. So what I'm doing, I'm using Archivista to store that, and the integration with Archivista was easily to just say, when you receive a new attestation, send a message to the RSTUF. So you can integrate, this is an example how projects can integrate with RSTUF and use that. And after that, you can go and sign these policies and those attestations and say, hey, all my deployment environment can trust on these policies, so we use this policy to verify our attestations before deploying it in production, for example. Yeah, that's a quick example. Of course, there are a lot of information here, but the idea was to bring this to have more conversations about that. So what's the current status of our stuff? I will leave to Martin.
So what we mentioned that RSTUF actually contains two parts. One is the services and the other is the command line interface. We're happy to say that RSTUF 00 beta for services is out. What does this mean, 00 beta? It means that all of the main features are there. Now we're just fixing some documentation stuff and some other adjustments. As we mentioned, we support custom delegation, which allows for many more use cases to be supported, and we have Helm charts so you can directly try it with your Kubernetes cluster. We have even a Helm chart for RSTUF demo if you want really easy deployment to try it out. About our CLI, CLI is a reference interface. You can just keep it if you know how to integrate with our API. That will work as well. We support all critical features and critical commands. We lack a few smaller ones. And what are our next steps? So we are preparing for a security audit of our code base. We have some quality improvements that we want to make, small quality improvements, and enhance our documentation. And I will finish with one funny story from this week. This week, we met with people from Civil Infrastructure Platform, and while we speak with them, we realize that they're already using RSTUF in their proof of concept. And we have interest from different companies as well, which is really exciting. And we are here to accept questions and to thank you for all of your attention.